Differentiation of natural logarithm is what we are going to cover in this lesson. Please don't forget to subscribe to the channel. Okay, differentiation of natural logarithm. Remember, natural logarithm is a log to base e, and sometimes it's written as ln of any function. So let us see how we differentiate it. So consider function y equaling to ln, some people call it ln f of x, but remember this is always a log to base e. So natural log is always a log to base e of any function. So now, like this, so how we differentiate is you differentiate the function after the ln, then you divide by the new function. So whenever you have y equal to this, you differentiate this function, you get its derivative, divided by the original function as you see there. All we need is to know how do we differentiate the function that is always there. Let us see some examples here. Differentiate the following. The first we have this. Let us see. Now your idea is to note out what is f of x. If I compare with my f of x with this, so here my f of x is going to be 3x plus a 4. If you compare this and this, so always this is our f of x ln f of x. So our function is here. All we need this derivative and also that. So to differentiate now f of x here, when we differentiate this we get 3. Of course this is the constant, it will go to 0. So when I differentiate this I get 3. So it means that now the y dx of this function is going to be f prime of x over f of x. So now my y dx is going to be my f prime of x is 3, then over f of x. My f of x is 3x plus 4. And that's all. We are finished. Differentiate that function. When we come to this, so now our f of x is this. So my f of x is 5 minus 2x squared. So we need the derivative of that function. So now my f prime of x is going to be, when you differentiate this, we get 0. When you differentiate this power multiplied this, we get 4. Reduce that power by 1, we get that 1 there. So we have differentiated that like that. So now, it means that now my y dx is going to be f prime of x over f of x. So now my y dx is going to be my f prime is negative 4x, the whole over this, which is 5 minus 2x squared. That's simple as that. So from here, they can also add you another thing. Let's say when they tell you differentiate y equaling to 3x. How do you differentiate this? I mean natural log of x. Sorry? This is natural log of x. Natural log of 3x. Natural log 3x. How do you handle this? Start now, your f of x is this. In simple terms, you can do this in one step. This would be, when I differentiate 3x, I get 3 over the original function, which is 3x. And so this will give you 1 over x. So you can do it in one step. Okay, let us come to this now. So up f of x from here is cos x. I need the derivative. So my f prime of x, we have seen, when you differentiate cos, you get a negative sign x. So from here, our y dx will be f prime of x over f of x. Now our y dx will be negative sin x over cos x. And now this is the proper identity. So now my y dx will be negative sin over cos becomes tan x, like that. As simple as that. Now this one I think is very easy. So the function is f of x is x. Its derivative is 1. Okay, let us now come to this. Now this one, we have our third at 8. That means that now we have to take this one here. So our f of x is going to be 4x plus 3 power third. Now here, we need the idea of product. I mean chain rule. What does chain rule say? If you are differentiating this function, so your f prime of x is going to be, we lower the power, maintain the bracket, reduce the power by 1, when reduce this by 1, we get negative 2 over 3, then differentiate the bracket, differentiate this, we get a 4. It means that from here, our f prime of x, this 4 and here, get 4 over 3 into now 4x plus 3 negative 2 over 3. So now we are going to put that there. So now from here, by dy dx, the derivative which is 4 over 3, 4x plus 3. Remember we reduced this by 1, which is negative 2 over 3, over the original function which is 4x plus 3 power third. So what happens there is that this third, we can take it up there, but our y dx becomes simplified to the simplest fraction. So when I take this up, it's going to be now 4x plus 3. Then here up I have negative 2 over 3. When this one goes down, when it goes up, I'm going to be having now a negative third using the idea of indices. So that now my dy dx is going to be 4 over 3 into now 4x plus 3. So when you simplify that, you get a negative 1, which will be the same as 4 over 3. And when you push this one down, we get 4x plus 3. And now that will be our answer. We've already simplified to the last step. Here the idea we have used, remember when you take this up, it's going to be down. This time is this, but this one is x power. I mean the whole power negative third. When you apply numbers of the same basis, you add the powers. So negative 2 over 3 plus this one now will be negative third. When you simplify this, that's why we are getting that. As simple as that. When you come to this now, here I'm going to apply some properties of logarithms. So this is multiplying this. We say if 2 are multiplying each other, we say this is the property I'm going to use. Log of AB is the same as log A plus log B, and also log of A over B is the same as log of A minus log of B. So those are the properties we are going to apply there. Hope you remember. So now here our y will be now natural log of E x. This is x. Natural log of E. Remember this is multiplying this. Then plus natural log of x minus 2 over x plus 2. When they give you these ones, first, whenever you start with multiplying or dividing, and you have natural logarithm, first apply natural logarithm, logarithms properties, so that you get a simplified equation you can easily differentiate. So now, instead I'm still dividing, I'm going to apply now that y will be, remember laws of logarithm, this one becomes x, natural log of E, this one is going to come here, then plus natural log of x minus 2, because I'm dividing, now natural log of, now this remains x plus 2. This one, the one which is divided now, then over that. But you know that always natural log of E is 1. Ln of E is 1. Because this is log of E. And we say natural log is log to base E. I think you understand why it's giving us 1. So now the log here I have 1 times this, which is x, plus natural log of x minus 2, and that's natural log x plus 2. Now instead I have a simplified version. This one is very easy to differentiate than the one which is up if we take it in one step. So you know now our dy The x is, when you differentiate x, we get 1, then plus. When you differentiate now this time we are going to differentiate this, we get 1 over x minus 2 using this idea. Now, I'm skipping the idea of letting, I'm skipping the idea of letting it. This idea is what I'm skipping. Because you can just see, when we differentiate 3x plus 4, we get 3. So start when we differentiate this, we get 1. This one is a constant, which is 0. So 1 over the original function. You remember you have a minus. When I differentiate this, I get 1. This is 0, so 1 over the original function, which is x plus 2. Now from here, you go on further to get the LCM and you simplify the whole thing. So look at this. So mind y, the x will be, the LCM here is going to be, this, remember this is over 1. So we get 1 times this. So our LCM is going to be x minus 2, x plus 2. Then this LCM multiplied up here. So this 1 goes here, this time. So this times this. We get, I think you can see, this is the difference of 2 squares, by the way. X minus 2, then x plus 2 is x squared minus 4. So that's why here I'm going to say now x squared minus 4. Then plus. This goes here, this time. So this times this, we get x plus 2. Then minus. This goes here, this, then this, minus this, we get x minus 2. What are we doing? You just set this divided here, the remainder is this times this, as simple as that. Okay. So this is going to give us x squared minus 4, then plus x plus 2. Now minus give us the positive. Negative 1 times x, we get negative x. Negative 1 times a positive, and then negative x, we get a positive. Now say the whole of this is the difference of 2 squares. We square this and then square this. Now, what are we having in that case there? Okay, we start from here. This is going to be a positive. First of all, this x is going to go with this x. 2 plus 2 is 4. So this is going to go with this and this. So that already one thing is going to survive. While the x is going to be x squared, the whole over x squared minus 4. And that is the simplified version of that. So that's it, remember. So that's how we handle natural logarithm. That's how we define natural logarithm. I wish you